Now we're going to look at the actual parts of a periodic function. A periodic function just means that it repeats itself over and over and over again, and we have to figure out what is the period of this and how many times does it repeat itself and how high does it go, how low does it go. That's like the kind of stuff we're going to be looking at. So these words are a change on our regular words like a vertical stretch by a factor of 2. We're now calling that an amplitude. Okay, so it's just a little bit of a change on the concepts that we've already know. We're just changing the words. So an amplitude is like how high and how low does a graph go from something that I call the amp line. That's not a real math word. It's a made up word, but I call it the amp line. So it's like, where is the middle part of this graph? I'm not talking horizontally, I'm talking vertically. Well, the middle part would be like right there because it goes up 3 and it goes down 3 from that point. So I refer to this, and this is just me, I call that an amp line. Um, I've heard some teachers refer to it as your average line or it's a vertical translation up. So your vertical translation line, your vertical, it's not an asymptote, but so different teachers call it different things. I call it an amp line. So amplitude, any periodic function, the amp is divided as half of the difference. Okay. The amplitude is defined as half of the difference between the highest and lowest values. In other words, amplitude is half the average. No, amplitude is half the difference. I'm keeping it in here anyway. I made a mistake. You watched me make a mistake. Don't care. The maximum value occurs at the crest. Because we're looking at wave patterns, this is a little bit of physics in there for you. Because periodic create wave patterns, we use wave terminology. Crest means the very highest point, and a minimum happens at something called a trough. So if we're looking at this, we've got our amp line there. That's an important line to be able to identify because when we're talking about graphing, this is your vertical translation up or down. And I think it's important to know. So for this one, it's happening at y equals 5. And when in 2 days, tomorrow, well, next lesson, when we start talking about transformations of these graphs, you're going to see why. Then our amplitude, this is a crest, and this is a trough. Okay, crest, trough. And they represent a minimum and a maximum for this periodic repetitive relationship. Our amplitude, if we were to say it's the difference between the crest and the trough, it's half of the difference. So 8 minus 2 is 6. 6 divided by 2 is 3. But if you've got your amp line on there and you know how high and how low it's going, it's just the distance from your amp line to the top and your amp line to the bottom. So the amplitude here is 3. The other thing that we need to be able to nip, not doing it, amp line, vert, crest, trough, done. Okay, oh, they're calling it the equation of the axis of rotation. See? The equation of the axis of rotation. That's what I call amp line. Amp line. That's my amp line. Amp line is the equation. Okay, determine the coordinates of the first peak and trough, the period, the amplitude, and the equation of the amp line. Okay. I don't know why, but for my eyes, the easiest thing to see first when I do these is the amp line. Like that's just the way my brain works, and I want to find that middle point where we're going up and down around. So for me, the axis of rotation, well, and for you, it's the same question. Axis of rotation would be this horizontal line that happens at y equals 0. Okay, your axis of rotation, unlike an axis of symmetry, your axis of rotation is always going to have an equation that says y equals. Axis of symmetry always had an equation that said x equals. All right, amplitude from this. From my axis of rotation, from my amp line, how far is it up and how far is it down? Well, we're going from 0 to 10, and we're going from 0 to negative 10. So the fact that we're going down here, it doesn't matter when we're talking about amplitude. Amplitude's just like how much higher and lower does it go from the amp line? Well, it goes 10 up from the amp line, then it goes 10 down, then it goes 10 up, then it goes 10 down. So you just have to know what the value is. Period. How long does it take for one cycle to repeat itself? Mm, mm, there is a repetition, and I, oh, sorry, sorry, my friend just called me from the Yukon. She needed some help with drafting a job that I would love to take. So maybe I'll move to Whitehorse. Nobody's actually watching this, so I'm not concerned about anyone saying anything. Okay, so here we go. Motion of a pendulum. What is the period? Well, it takes 1, 2 seconds. So our period is 2 seconds. First peak. I'm going to make the first peak purple. No, pink. Make the first peak pink. First peak happens right here. And I'm going to make the first trough. Oh, that's hard on the eyes. There's the first trough. Okay. So, hours of sunlight in Windsor, Ontario. Wow, we have a lot more sunlight than we do. Okay, first peak. I made that pink. First peak happens there. First trough. Looks like it starts at a trough for this one. Happens there. Okay. Period. How long does it take to go from here to the next trough? Ugh, that's not perfectly on there, is it? I don't know, like there? Oh, is this supposed to be a full year? 365? That, yeah. Are we surprised? Okay, let's assume 365. 0 to 360. We're going to say it's 365 days. That's how many days are in a year, right? Amplitude. Okay, where's my amp line? I think it's there. Let me just see for a second. Up almost 2, down. This is gross. Oh. How many spaces are between this? There's like 1 full space, 2 full spaces, 3 full spaces. So let's go up 1 full space and a half. This is disgusting. I'm going to put my amp line there. Oh, look at that. Look at that. 15. Oh, would you say that's 15? I wouldn't say that's 15. Minus 9. 10, 11, 12, 13, 14, 15, 16. Okay, and we're saying our amplitude is 3, and then our axis of rotation is happening at y equals 12. Good. Don't like it though. Don't like it at all. That was a bad diagram. And there's a 12 just, hanging out down here because it doesn't need to be there.